其实你讲你要慢慢拿时间啊，你要慢慢拿时间，再找一个跟你一起哦。诶，冰兄，可以慢慢操作电脑啊，等一下啊，就每一个人开始之前不是，那个人结束过后，我有 list 嘛，对不对？然后在那个人上来之前，把他的 slide 开好，OK 啊。然后你要确保这个外面有这个框框，因为这个框框才代表有录进去，
可以，
你会吗？好像有些人号码不太对，还是对啊？现在，对啊，应该对啊。
有 list 吗
有，在那个 Teams 里面有。
？Teams 里面有，应该可以。
你刚刚差232，234应该没有了，就一线应该放好了呀。到时候这样 OK 了，这样全部都有。在那个人讲完过后，就可以开始
他问题
换赛
的时候我就可以
啊！
换。
不用，等他回答完毕，等他下去，你就可以换 for 下一个。
可以。
啊，OK 啊，要找一个人跟你一起算什么啊？就是一个负责看图片，一个负责对面。1630秒后，30秒过后，让我想一下，那30秒定上下，定上下。我会慢慢听，如果他不听，里面有那个问题，30秒过后还不讲那2个问题，因为那把 Q&A 时间，等上下过后再 start，就 start 上，Q&A 时间有2分钟半。OK，Q&A 时间也是这样，Q&A 时间最多有2分钟半。第一分钟听一下，第2分钟听一下，然后说里面。找一个跟你里面有关系，大家时间有没有算错的？或者你提醒他听。
好，OK 了。
哎，我哪个？你过来跟他们一起算时间。哎，还有人还没有来啊？你们可以叫一叫你朋友来吗？我们 start 之前可以拍个照先，然后我们开始 start。叫一下你朋友还有谁啊？恩慈他们啊来了，还有谁来着？生全部到齐了，子英有来这吗？子英，问一下。男的呢？还有谁啊？哦，苍云他们，苍云谁啊？苍云哦，玉婚那一间 异想那一边，其中你有放3个版本，哪个是你的啊？所以哪个版本是你的？等一下我们要帮你开啊。第二个啊，这个啊有2个，第二个你是16:2还是17:2？16:2，16:2，OK，15哎，怎么15不进去？15是谁啊？汉堡啊，汉堡，一箱，一箱，一箱哎，现在没有放上来哦，
比个高了是他，就会
开出去看一下。
所以
雨崩哦，这个现在没有放上来呀。15不是，它是 second half 不是
16
啊？它是16，谁是16？连会期怎么放16呢？会期是17，连怎么分词是17了？
说吗？诶，换鸟怎么背起来了个？对啊，
1、2、3、4、5、6、7、8、9、10、11、12、13、14、15、16、17、18、19、20。一想呢？啊，message 一下，message 一下。你们不是住同宿舍吗？没有去敲他们呢？你打给他，剩一箱啊，对不对？OK，啊，你是什么号码？你是16，OK，67。Hello，Hello，我好像没有看过紫菱的正脸呢，从来没有看过。今天看，你也是今天看到？啊，你一开始就看到，还差一响是不是？Hello，他的 slide 放了吗？他到了吗？看一下没有？OK，OK。可以说，before 我们 start，我们拍个照。今天好像有一位来宾是吧？谁的朋友啊？要不要自我介绍一下？啊啊，OK，好，直接欢迎你。说你是慧琪朋友，OK，等下可以麻烦你帮我们拍个照吗？好，等下我们拍个照，然后等下全部人在全体拍个照。等下我讲解的时候，我讲盯的时候，你可以盯一下。 最大声啊，最大声，最大声。
我要给人家看。
再等一下下。before 一箱来，我觉得我们用这边来，这边比较空，还是这边？这边比较空一点。这边你们能不能全部来把你们东西留在那边，然后先坐过来这一扇，先坐过来这一扇，这边比较空，你们东西可以放那边，我们坐在这一扇拍先拍一个全部讲员的照片。啊，我坐哪里？不是你们坐先，我可以找我一桌的。对啊，你坐先。呀，坐前一点啊，坐前一点，不用拍到这么后。呀，可以。Yes, yes, yes. OK，等一下来我们就拍一个照 before start。可以。分钟哎，这样久了哈，他没有反应。哎，一翔，你要那个 slide 放上去啊？还没有？OK，你等一下放啊，你是后半段不是？OK，好，可以请子谦吗？帮我们拍个照 before start。
来看镜头，好了没啊？来看镜头，一二三，对张，一二三，要几张？好看啊，大家都很帅了没？
Okay. Okay. So before we start, let's brief. Let's brief again before we start. So, our time is quite compact. So you have the program right in your hand. I posted in Teams. 有看到吗？ Yeah, 你可以 refer to 那个。So we have two sections. One section is before 10. The other section is after 10. And our time is quite packed. You only have 1 minute to present. So after 1 minute, you will hear a ring bell, okay? To tell you 1 minute, you should stop. If you don't stop, I'll give you extra 30 minutes. Sorry, second. Okay, second. And then you have to finish already. Okay, if you don't finish, I will stop you. I'll cut you. Okay, and yeah. So three bell rings meaning I cut you already. Okay, and then Q&A section. Okay, after 1 minute, you will also hear one bell ring. Okay, and then 2 minutes you will hear second, yeah, 2 bell ring, and then extra 30 seconds you will hear 3 bell rings. Okay, okay, so 不用联系就叮叮叮就好，叮叮叮就好。OK， OK, clear? OK 吗？ So basically you have 1 minute, 1 minute presentation, 2 minutes Q&A, okay, and then extra 30 minutes if required. Okay. sorry, 30 seconds. Okay, 耳朵很好啊，你们。So 30 seconds. So yeah, so 1 minute you have to catch people ears. So in this 1 minute you need to catch people ears. If you don't catch people ears in 1 minute, then people will just go. Okay, their attention will just disappear. And then after each 1 minute presentation, all of you can ask questions. You can start from me. If I got a question, I ask first. And then after I ask, you can ask, then the student can ask. So if you ask good question, you get 0.5 extra marks. Okay, for each question you ask. So you can get at most 2 marks. And then so the person who answer the question will also get extra mark, but this extra mark is added in your presentation mark because I can see how you react to people question. And then there are two mics here. Okay, so there are 2 mics here. One is for speaker, the other one is for you, all of you, Q&A section. So there's a rule using this microphone. Once you stop talking, turn it off. Okay, because we cannot have 2 mics together at once. Okay, once you stop talking, 你一停止讲话，你把嘴巴闭起来，把麦起来。OK， 你的麦就是你的嘴巴。OK， once you start talking 才 turn on。OK 吗？明白吗？一次只有一个麦，每一次只有一个麦可以有声。OK 吗？有问题吗 ？Clear？ OK， 如果没有问题 ，we will try to start the first one. So first one we have海伦。需要关灯吗？你们看得到吗？这样子你们觉得够亮吗？啊？你想关？关啊 ？OK。哎，关灯吗？要小一点。这个。这是关灯。关灯对。大当情。等一下。我这上面你再看一下。可以啊。哦 ，OK， 谢谢。有麦，还在。这个可以关出去。行，哦，经过。是没有灯就是关了。Okay. Okay, so first we have Fibonacci sequence in sunflower seeds distribution by Kailun. Okay, so good morning everyone. So my topic is Fibonacci sequence in sunflower seed distribution. So what is Fibonacci sequence? So Fibonacci sequence is a series which each term obtained by adding the 2 previous terms. So we have the recursive formula like here, and then when we notice that when we taking the ratio between the 2 adjacent Fibonacci sequence, we will get a golden ratio. So this is the Fibonacci sequence in our nature. So you can see that the picture is in spiral form. So my topic is in the state distribution. So when a whole circle 360 degree divided by the golden ratio just now, so we will obtain an approximate angle which is 222.5 degree. So this angle also corresponds to an exterior angle which is 137.5 degree, which is also known as a golden angle. So each spiral of the sunflower seed distribution, okay, having the golden ratio which is 137.5 degree. So this arrangement in the Fibonacci sequence can maximize the efficiency of packing seeds, and this also maximizes the exposure to sunlight for the sunflower plant growth and reproduction. So
This is the seed growth one. So suppose the seed will grow from the center, and each seed will turn 137.5 degree. So we'll obtain this spiral, and then when we count the counterclockwise spiral and anti-clockwise spiral, we'll obtain the Fibonacci sequence.
Okay, thank you. Can you go back to your slide?
Second slide. This one.
So, that sequence is not a series, right? Just a sequence.
Oh, yeah. Okay. It's my mistake.
Okay. Any question from the audience? Any question from the audience? Golden ratio. Okay, so can you go to the last? Okay. Can you explain again this one, how to see the golden ratio?
Uh, 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 this picture actually is come from this one. Okay, so every sunflower seed, okay, it grows from the center, and where the new seed is grow up, the previous old seed will turn 137.5 degree, and then grow like this one. And then when grow until this one, but this also this only I restrict no continued growth. But if it continue growth, it will obtain more and more, maybe 30, 34, and then 55, and then 55 continue the Fibonacci sequence.
So is the radius increasing?
Yeah, the sunflower depends on the sunflower flower.
So the radius does it increase as a golden ratio?
Pardon?
How the radius increase?
How the radius increase? You means the flower?
The seed. First, can you go back to the previous two slides?
Yeah.
So if the radius don't increase, right, then the seed just grow into one circle, right? But the radius increase such that it will spiral.
Uh-huh.
So does the increasing radius follow golden ratio?
I didn't cover this part yet. Yeah.
Can you try and think about it?
I think it also follow the golden ratio. If not, if not follow the golden ratio, then the spiral maybe will affect it. Yeah.
Okay. Can you try and check?
Yeah, no problem.
Okay, so you have two more questions to answer.
Yeah. Okay. So hello. I think math is useful because we use mathematics in every day, from buying some things and until we explore some technology and space problem. Yeah, so and then why I taking the mathematics course, because I want to share the interesting mathematics knowledge to my student in future. Yeah.
Thank you, Tyler. It's okay. So next up, we have Yu Hong. Yu Hong to tell us the golden ratio in the human body.
Present.
加减那边是不是一个 string？
加减
上面
OK，
有这个。
开始了。
介绍吗？
对。So, good, sorry. Hello. Good morning, sir, and everyone who are participating. My name is Sun Yu Hong, and today my topic is about golden ratio in human body. So, at first, we can notice that in our personal food, when we looking someone, our first impression is often influenced by their height and the properties of their body. So in these things which are particularly evident in environment and modeling industry. So these two examples that we can see in the environment and modeling industrial. So next is about uh about the ratio. So what is the spatial ratio? Because what is the spatial ratio that representing in the environment and modeling, and what is important in the maths? So this is the golden ratio. So we can recognize that the number is very approximation to the numbers, which is calling the golden ratio in real life in maths. So this is the graph. So we can also find that the golden ratio also can recognize in the Fibonacci sequence by matching the consecutive Fibonacci number nearly to infinity. So the study support that maths have a harmony aligns with humans' perception of beauty. So maths and beauty have shared a natural connection reflected in real world proportion. So thank you.
Any question from the audience first this time? Audience? So that two model, you know them, ah? You know
Yes.
them, so you like them.
Especially in my opinion, I didn't like any idol because I think that they are beautiful, but how to say although they are beautiful, but because how to say you can say I like them.
Okay, so you like them. So okay, so do you want to address the two questions before you know?
Oh, okay.
Mm.
So in my opinion that maths is useful not only in maths in useful not only in the reality of using it to some industrial problem, but it also can increase our sense and reasoning when we facing any problems because it can improve our critical thinking. So besides, why I choosing the maths course because I think it's a very wide application in real world because I didn't know I want to working for what in the future. So I choose math as my first course. Thank you.
Okay. So for 子轩 right, actually 我们每一题每个人都有两个问题，我有 two questions 在管，你知道？你知道啊 ？OK。所以第一个问题他们会回答是为什么数学有用，第二个就是回答是学数学来干嘛。Okay, so next up we have Check You. Check You will also talk about Fibonacci sequence, but this time it's in painting. Again, painting. So first we have nature in plants. Second we have in human body, Homo sapiens. And third we have this painting. This is a human.
Hi everyone, my name is Cheryu, and today I'll be talking about Fibonacci sequence and how golden ratio and Fibonacci sequence contribute in the harmony and beauty in paintings. So first we start off with the Fibonacci sequence, of course, and from that we can derive the golden ratio, which is approximately 1.618, and with that ratio we can form and construct the golden rectangle as well as golden spiral by adding bigger squares with the side lengths that correspond to the Fibonacci sequence. And the reason why the golden spiral is used widely across so many paintings is because of its visually appealing look. It is incorporated by artists to create a better composition and as well as to guide the viewer's eye through the whole art piece. And with placing the focal points along the spiral curve, artists can produce a better sense of movement and harmony, such that it highlights important components in their painting. For example, in Mona Lisa, the spiral starts at her nose, which is the focal point, and then outwards towards her eyes, the face, the background, ultimately creating a flow that captures her captivating gaze. And that'll be all for my presentation.
Previous picture there. Maybe one more. Okay, yeah, cool. Okay, I recognize this picture. This is from a Uniqlo.
Yeah. Not exactly. It's
Exactly.
from Uniqlo.
Yeah, Uniqlo. I think they printed this in their shirt.
I mean, it's a famous artwork.
Yeah, sure.
Yeah.
Okay, sure. Because they also print Mona Lisa on the shirt. Okay. Here is what Kylan want to look for. That your sunflower. Okay. So any question? Audience? Any question? Your friend. Yeah, I mean, I recognize that you and use this word of harmony. Yeah, I think it's quite true. How this maths can match with the harmony of the nature, and then why people tend to kind of image in their eyes, right, or in their mind, because they see that the nature follow these rules.
Yeah.
Yeah. They see from sunflower how they distribute. Right? I think that is very natural, this kind of distribution. Okay. You want to, before you leave,
Yeah.
address.
I can be honest, right?
Honest, can, yeah.
So if I were to convince a layman about why math is useful, I would convince them by showing them interesting results from math concepts or math problems. For example, this Fibonacci sequence. I would tell them that math can be found in a lot of fields like nature and architecture and even the human body. And for the reason why I chose this math degree is solely because I was interested in math in high school and I more like computational math, and then I sort of just went into this degree without having too much research. But then I already made my choice, so yeah.
Yeah, I never know that you got such a good English command. You seldom talk inside the class, right? Yeah, I don't seldom listen to you. Quite good. Yeah, so I mean, our experience is the same. We know how to compute and when it's to make degree. I'm the same also. Okay, so next up we have Wei Chen. Hey, so whenever one speaker finish, right, the next one can get ready. Okay? Because you know who is before him, right? So you can get ready first. Okay, so next one we have Wei Chen. Tell us about Pythagoras theorem in lecture, right? Yeah. You stop your.
Sorry.
On the. Okay.
Hello. So good morning. Okay. Good morning, everyone. I'm Richard, and my topic is Pythagoras theorem in the architecture. So first, we are going to the Kepler triangle. Is a special right triangle that showed the
side. So they show that the side of the ratio is 1 to the square root of 5 to the 5. So it's showing that the 5 is a golden ratio. So it's clearly combine the property of the golden ratio with the Pythagoras theorem. Next, this is the pyramid of the Khufu is a great pyramid. So I'm showing that is a golden ratio. So based on this article, I'm averaged the 20 order from his base size and the pyramid. So using the Pythagoras theorem, we can find it the apothem is 186.57 meter, and so dividing the apothem by the half base is 1.619. So it's a golden ratio. So next is the pyramid. So there's so it's same for the before the method. So but the base side and the length is different. So unfortunately the question result is 1.744. So it's further away from the 5. So we conclude that no, all the pyramid architecture is a golden ratio. So that's all. Okay, thank you.
Okay, thank you. So actually for this time round, right, in your class, right, I never go through most of your draft. So I also first time listening. It's different from what I do from my previous batch. Usually I will read their draft first. So this batch I also listen from scratch. So okay. So you said that not every pyramid related to golden ratio, is it?
Yeah.
Okay. Golden ratio or Pythagoras theorem. So why suddenly relate back to golden ratio? I thought you were talking about Pythagoras theorem. Okay.
So this is a Kepler triangle that's denoted by the Jonas Kepler. So there is a special right triangle. So the hypotenuse is 5. So it's a golden ratio. So we can denote it combine the property of the golden ratio with the Pythagoras theorem.
Okay, so you mean that this triangle follows Pythagoras theorem, but also their ratio of their three sides following for the ratio between these three sides,
yeah,
proportional to square root of the ratio.
Yeah.
Okay, and then so I mean, so you check that one of the pyramid doesn't follow, or all pyramid doesn't follow.
One of the pyramid.
One of the pyramid doesn't follow. So what happened to that pyramid? Yeah, still there or?
He Kevin.
Which pyramid can you show us again?
This one, pyramid.
So what's the apothem? Can you use the picture to explain when the?
It's after he came in. I haven't. I did not find the picture that before he came in. So
no wait. I mean, what's apothem?
Apothem is just the strike length.
Strike length. Do you have a pyramid picture? The picture.
This one?
Yeah. So where's the apothem? That slanted.
Yeah.
Or that. Okay. Back to the last one. The last pyramid. Where do you get this measure from? Where do you get this number?
Based on his article.
Oh, article.
Yeah.
Okay, then so what he concluded, if he doesn't follow golden
ratio. No, he just mentioned that the pyramid. So I'm taking the data to calculate that the result.
Okay, thank you. Before you leave.
So how to convince the layman math is useful? For me is I will tell him that because everyone has a curiosity, right? So you study math, it can fulfill your curiosity. Even though the math is not direct, not strictly to the field, but it's helpful for the field. So next is why I'm choosing the math for degree is just for interest. only. Because since I saw more, I was small, I will saw the comic. I don't know what is the name. 叫明天的数学王是吗？ I don't know. I forget his name. So he is introduced that the probability of the rock paper scissors, and next one is the golden ratio lah. So it make me feel interest in the math lah. So that's all. Okay, thank you.
Before you leave, so you mentioned about curiosity of others, right?
Yeah.
So there's a real life problem here. What if that person don't have curiosity in maths? Bring out his or her curiosity or not?
I think all of the people has the curiosity, right? Even though you don't have the curiosity for any other part, right? You need to think about how to use it tomorrow, right?
Okay, so your axiom is all of the people have curiosity. Okay, thank you. Next up, we have Xiao Peng. Xiao Peng will tell us optimal price model and the grant function.
先听的话，这里
Next few follow-up with Xiao Peng, I think all of them are related to finance side, so we'll put them together.
Good morning, everyone. Today I'll talk about the optimal price model and the Lagrange function. As we know, the profit is influenced by various factors such as sales price and cost, and so on. To simplify it, we can consider the profit as a function f of these variables and subject to some constraints. So our goal is to find the optimal price that maximize the profit function f. First, we need to construct the Lagrange function in this formula, and then we need to solve the system of equations derived from the partial derivative of the Lagrange function from x1 to xn, and associated with constraints. And finally, I want to mention that we may get from the system. So then we just evaluate f at all sourcing points and then compare them. So we can get the optimal price according to the maximum value point.
Okay, thank you. So this is the part that we didn't cover in the lecture, right? Any question from the audience first? Yeah. Lagrange function using equation.
Okay.
The second line.
Okay. Well, so my question is there any further benefit of define that function?
And why you do that?
I need to write something.
Write something.
I can give you a simple case. So that we have a function f. Then we let's see the curve line on the surface of G. Vector function to represent the curve C, just like this. And our goal is to find the extreme value of f. So if there is a point the extreme value of f, we can find it. There is a t0 to and then we use a composite function f and rt. H. Also is t is the extreme value point, so h t0 is also the extreme value. ht0 is also the extreme value. Then we can get the 0 t0. Then we can use the chain rule differentiate. In 30 seconds.
30 seconds. Don't have that much more time.
Finally, we can get random.
Okay, I think you guys can discuss later.
Okay.
Too long already. Before you leave, can you tell us why magnitude?
Math is useful because it can apply to many fields like the architecture, biomedicine, and even it can to make money. Why I choose math? Because I think it's features that some features that attract me most because we can use some consensus language to describe a complex system. We can use consensus language to describe some complicated things. Consensus language 不是简洁的语言
Precise
啊
language.
consensus language
Precise language.
Yeah.
Precise language.
yeah.
Okay, thank you. Give me a one.
没有看。
对。
看你好强啊！
icon 啊，那找不到哎，那个头找不到。Okay, so we have Yu Liang tell us compute compound interest, continuous compound interest in economics.
Hello, testing. Hello, testing. So yeah, good morning everybody. So I'm Yuliang and I'm gonna discuss on continuous compound interest in economics. So next is on the formula of compound interest. And firstly, we denote by AT is the future value and the principal. That the equation is followed by the initial principal, E Euler number, and R is the interest rate, and T is the time in years. Next is the problem statement, and we see that the initial value here is 200,000, and the rate is 5, and investment year is 5 years, and we need to find the interest on over 5 years. Next is the solution, and we know that from a problem statement that I've talked about, the initial value, rate, time, and also the compound in years. So we start by a fundamental compound interest formula. And next is the basic one, the basic compound interest formula, and we want this in the one inside here to converge to E, and that's why we need to add a limit in front of it. And next is we split the n over nt into n over r times rt, because we acknowledge that is the total number of compounding periods, and as n goes to infinity, and we let k equals to n over r, because we want this to goes to the definition of E, and we get this here. And next, we recognize that it's actually the definition of E, and also we get the original formula that I presented previously, and we apply it to our problems, and we get our solution here. And thank you.
So thank you, Yi Liang. So you make your problem statement very clear now, what to solve. It's quite good. Any question for Yi Liang? Sharon? If no question, maybe you can address the two questions for you.
Okay, so hello, testing, hello. So yeah, so basically we are using math in everyday lives, and we are managing money on ourselves. So basically math is useful not only in pure math side, it's also on the applied side. It's almost using it everyday life, especially when you are transferring or doing something you are doing, transferring in securities and all those stuff, we are using maths. So why I choose maths is just a fundamental, or just my stepping stone to my degree in master. Thank you.
Okay, thank you. Thank you, Yi Liang. So next we have Yiping. Yiping topic, the public. Marginal close. Okay.
Good day, everyone. I'm here to give a presentation about my project to Margin Coast. First, give an introduction. CQ is the total cost function, where Q is the output. The Margin cost MC is defined as MC equal to DC divided dQ. And we also have the production function FLK like this. Then we look at the problem. Here we want to maximize output from the production function. We have a firm production function like this, and the labor and capital cost 6 and 8 respectively. Now we also give that we have 280 spent towards cost. We want to find the margin cost and the maximum output. So we solve this problem. We want to maximize the F and FLK function, and we have the constraints 6L plus 8K equal to 280. So we first get the gradient F like this, and then use the Lagrange multiply to combine the gradient of product function with the constraints. We can get the relationship between the L and the K. Then we substitute the constraint and get the maximum output and the MC. That is my presentation.
Can you explain a bit why that production function makes sense to consider the fractional power of these two variables? Can you like give some opinion why this function makes sense?
This is the definition from the economics, actually.
Yeah, so why they naturally will consider this kind of function? 为什么必须考虑这种现实中
because in X you need to fund the labor capital with the production relationship. You make because you are in
So for example,
in
right,
business.
okay, can I give you an example? For example, why not we consider exponential of L or exponential of K or square root? Okay, maybe not square root in this case. Exponential L, exponential K, or log L, log K. Why is a power function? Makes sense.
Power function.
Yeah, why they consider power of L?
I don't.
You don't.
Yeah.
You try and figure out,
Okay.
include in your project.
Okay.
Other question? Okay, so before you leave,
Why? First question. If I decide, if I recommend some people to choose math, I think the reason maybe, when you learn math, you will, help you in financial planning and improve your logic make. And why I choose math? Actually, I want to in master go to the computer science or maybe finance further. So I think the math is the foundation of this subject. So I choose math in my in this time. Yeah.
okay, thank you. Okay. Next, Bình Xiong, tell us about loan.
Installment loan.
Installment loan.
Hello. Hello. Hi, my name is Bing Xiong. So today I'll be presenting installment loan. So for my problem set, I want to pay off my debts worth 10K with interest of 16% compounded semi-annually, and I want to pay in 3 years with a fixed amount of periodic payment of 2,100. This amount. So after that, I calculated a table where most of the bank uses if this one. So I see that the principal payment, right, there's a sequence for it. So inside my report, I used the geometric sequence to find out the formula, which is this for the principal payment. So PN here is our principal payment, R is our periodic payment, I is interest rate, N is number of times you pay, T is numbers of years, M is conversion period. So how do this apply? First, maybe I want to check my second term, which is this one. So I will apply the formula inside, and I will get this P2 is equals to 1472. Then after that, I'll calculate, I use geometric series to calculate the total installment loan. And I got this formula, and after calculating, the whole total installment loan is 10K. So basically it's like this. Thank you.
So do you mean that you get the data from the bank and then you develop their formula, or the bank?
This one I use Excel sheet. This periodic payment, right, is from PMT formula. And after that, the interest is calculated by the outstanding balance. And the principal payment is this periodic payment minus the interest.
So my question is bank really use that formula to calculate your
I see online they say they use this.
understanding?
And it's also a better visual for us to see how many is left for our outstanding balance.
So we borrow 10,000
Yeah,
and each year has 16% charge.
16% compound annually, meaning 8% charge per payment. Because our interest is 16%, right? If we paid twice a year, we have to divide by 2. And then we can calculate. So the interest is actually 8% because
Okay, so you borrow 10%. So next year they multiply 16% or 169. Then you need to pay 116%.
no.
How you-
Okay, so for the balance, I borrow 10K. So if my interest is 16% and I pay once per year, so I will just times 16%. But
you don't pay,
If I don't pay, then I think that's
still 16%.
this one haven't gone through yet, honestly.
Okay, so if you pay once, they charge you 60%. 60% of 10,000 or
Of the 10,000.
of the 10,000.
Yeah.
Ah, okay.
After that, the next payment, right? You take the 10,000 minus what you paid,
Then take
and then
60%.
the outstanding balance times 15% again. If I paid one times.
But you still need to pay the previous 60%.
If I don't pay.
Huh?
If I don't pay.
But you still need to pay the
Yes.
Okay. Any other questions?
The two questions.
Yeah.
So how do I convince a layman to learn maths? So basically maths is we will see it every day. Basically, if you go into a grocery store, you buy this, buy that, end up in the counter, we use summation to calculate everything. Then suddenly maybe you get discount, you multiply it and minus the price. After that, if you are going with a group and you want to divide all the like you want to pay your own things, then you use division, use quotient to divide everything. So for me, I think maths is quite important in our daily life. So why do I choose maths? Actually, my first option was not maths. During high school, I'm good at maths, so I wanted to do things related to maths in the future. So I gone through like IT, finance, and actually my last option was maths. Then I see through all the program structure of IT, I see that it's a bit bored and every day program type coding. For me, I don't like that. So after that, for finance, right, I see that they study something called law, and I hate memorizing. And after that, I gone back to maths and I see all the program structure. I see it's quite interesting, so I take maths as my choice. So that's all.
Okay, thank you. Thank you. Okay, next. Chung Xiang will tell us about one period of pandemic. Okay, maybe we need to speed up a bit. Speed up a bit.
Hello. Mic test. Hello. Hello. Good morning, everybody. So my topic is period of pendulum. Okay, so our goal is show that to find the period of the pendulum by the small angle and with in general any angle. So I hope that everybody have seen this before. Is the pendulum clock. So this is we use the pendulum clock and do the force analysis. So here you can see that by the diagram we analysis the force, we have this the first equation. So another than we can use the Taylor series to very easy to prove that this limit. So by applying this limit, we can find the string, we call string constant. After that, we can find this formula in the small angle, I mean the period. So in general, how can we find the in general any angle formula? So again, we use the diagram that we analysis the force of pendulum. We have this ODE. So with solving this initial volume problem, we have this T naught. So by symmetry, we multiply 4, we have this formula. So the reason is negative pi to pi. We can use ratio test to get this. So we can see that the small angle is very easy, but
when the theta is any, is general the infinite series come into the game. Thank you. Okay, this question in high school we already consider the angle is less than 5 degrees. So we can do the approximation like this. The initial angle. The approximation to get the simple formula of the period of the pendulum.
So it's
Less than 5 degrees. 5 degrees. I mean 5 degrees.
5.
The initial angle. Okay. I just speak.
Okay.
Okay, I answer them together. I think that study mathematics can foster our critical thinking. I think critical thinking is a very play a vital role in nowadays in this complex world. So I think that I can learn this skill through the undergraduate in mathematics. So that's why I choose mathematics. I think this can bring a lot of benefit to me. Like it can bring, maybe I can use this skill to make a lot of money in the future. So that's why I don't go to study finance or actuarial science, because I think other course cannot learn this skill. So it can help me to determine which one is right and which one is incorrect. So I think this is my answer. Thank you.
Jian Peng will tell us about active noise control. Can Xiaopen erase your writing or not? Your own writing? Yeah.
So good morning, everyone. Today we'll talk about active noise control. For active noise control, we have 3 main steps. So first of all, we translate the original signal into the frequency domain. Then we identify what is the noise in that frequency domain. After that, we generate an inverse sound wave to eliminate that noise. So first of all, we have the original signal, and we will use a Fourier transform to transfer into the frequency domain. Then, when the modulus of f omega is small enough, we will take that as noise, because the modulus of f omega kind of indicates the importance of that frequency in our signal. And once we have the frequency domain of the noise, we will use inverse Fourier transform to transfer into the inverse sound wave, which can cancel out the noise with the original one. And we add a minus sign here, so the inverse transform will be negative. That's the end of my presentation.
You do your noise cancellation in this case after you compute the inverse Fourier transform, right? Okay, so after you do Fourier transform, how you like cancel out your noise?
So here the inverse sound wave is the time domain sound wave. We just play this noise. We just play this wave. So they will cancel out with the noise.
Did you prove that?
Yes. Yes. It's called, this is just.
You add the inverse function to your previous function?
Okay.
Are you trying to add the big F noise to the small f?
This F noise is the frequency domain, is in the frequency domain. So if you add it in the FT, is meaningless.
Okay, so then how reality the sound?
No. The small t is meaningful.
Wait. So are you trying to cancel sound in real life?
Yes.
So how this computation can cancel sound in real life?
The small ft that I have here, if you add it to the original one, you will cancel out. I prove it.
So mathematically that cancel out?
Yes.
The coefficient that
0.
is 0. Did you write in your project? Okay, I want to see in your project.
Okay.
Okay, any other question?
Third page.
Third page. I using maximum. Oh, you means that why I take the ratio of the maximum of the modules? Because of f omega is kind of like indicates the importance. So if tau is just a constant, if your signal is very loud, and you will be not useful anymore. So this is like you can use for any signal if you choose the maximum of the modulus. Okay. Yes, instead of using just a constant, because f omega is just the Fourier transform of f omega. It's related to the duration and the louds. This the value of f omega, the modulus. Yes, amplitude. The absolute value of ft is the amplitude. Okay, so why math is important is because you live in this life, you live in this world, you're gonna expertise in something, and as we do here today, and math can useful in every field, like finance or even biology. Yes, so I mean that you have to do something with a living, and everything is related to math. So that's how to convince people math is important. And
do
what?
You think you said these people will get complete?
Why not? I mean,
maybe they just don't get complete.
Why?
I don't know. You ask them.
Okay. And why I'm trying to choose math as the major is that, okay, so nowadays the world is growing very fast, and I learned some new things in 4 years of my college, and when I graduated, I don't know if whether it's still useful if I choose, like, for example, my previous major, computer science or things like that. But mathematics is like the knowledge we learned is from 100 years ago, but you can still apply it nowadays. So I think that's a benefit of mathematics to adjust this fast growing industry. That's why I choose math.
So last one in this section, we have Chang Yin. Chang Yin will also talk about Fourier transform in the speech recognition technology. So speech recognition technology is the one like WeChat. If you speak to the WeChat, and WeChat will turn into Chinese text, right? Yeah. Okay.
Hello everyone. My topic is application of Fourier transform in speech recognition technology. Time domain signals contain a vast amount of information, but lack a clear description of frequency components, making it challenging to distinguish between different speech. In simple terms, converting complex time domain speech signals into frequency features is problematic. So the study of calculus, we understand that the definition of Fourier transform, and the definition is as follows. Inspired by this, researchers began applying the Fourier transform to convert connected complex time domain speech signals into frequency domain features, thereby enhancing the effectiveness of subsequent the speech processing and the recognition. Thank you.
Do you do actual computation in your project or not? How you do Fourier transform? Can you give some concrete example? Like I give you a wave of frequency, right? So when people speak, they speak with wave frequency, and then how they read the transform, like Fourier transform information from this sound wave. Do you understand what I'm saying? So you have a sound wave, okay, and then you say that you do Fourier transform to sound wave, right? And then how they turn this information into text. Or yeah. Can you comment a bit?
I think at first we collect the speech signals with time domain. Then we use the Fourier transform to change it into frequency domain. Then we are more we process it more easier.
I mean, do you have an idea, like, for example, I say, thank you. So how, after Fourier transform, thank you, this sound, how, like, you know that this is thank you or something else? You know?
If you say thank you, then we connect your speech signals to a image such as then we record it into your computer. Then you get a time domain function. Then you use the Fourier transform to change it into frequency domain.
Can you try and write out in your project? For example, this example, how you recognize thank you. And different people say thank you differently, right? Like Jingson said thank you. Thank you. I learned thank you. Enjoy. Thank you. So why all these translate to THANKYOU? I mean, you discuss in your project.
Okay.
Try and discuss in your project. Okay. Okay. Yeah. From
or how I can convince laymen that math is useful to study, I would say that all engineering and science disciplines contain math and requires strong mathematics knowledge to support. The main reasons why I first choose to study math degree is that math is a panacea. To be honest, when I choose my major, I didn't have a dream major. However, after careful consideration, I decided to choose math as my major. So that I can choose most of the subjects that I may dream of in the future when I pursue graduate studies.
okay, so this concludes our first part. So let's take a 7-minute break until 10:20 So we have kind of delay because
We delay starting time just now. If anyone in the second half that need to leave earlier before 12, can you let me know so that I swap your thought to the front first? For example, last time Xiao Yang, right? You need to leave at 12 or I mean 11, or you can drag a bit. Maybe I mean new ending time will be around 11:15 until 11:30 like that. Are you okay? You okay? Then we will proceed with the same schedule. So let's take a break until 11:10.
right? 10. 30. 时间到，你直接顶上去有没有？啊，对啊，也是可以，把你调。有啊，有哦，对啊，也是可以啊，没事，哪个运动我们应该哦，可以变那个啊，对，可以哦。如果我问掉，你再问另外一个，想不到。OK，我会讲。OK，一讲完你就举个手，就看到。现在放下来，放下来。 跟下面一样。跟图书馆在吗？来，你先来。啊，我先。你以为？
Okay.
Okay, second half of the talk will be focused on what we did after midterm. So it's about parametric curve, the phases, the multiple integral. So let's start with Jinsen. Jinsen will talk about a double integral in a high dimensional probability.
Everyone, my name is Chu Jingsheng and I'm presenting double integral in high dimensional probability. So the problem set is the supervisor of JSC Cinema claims that the average time of customer waits to buy ticket is 10 minutes and the average time they wait to buy popcorn is 5 minutes. And we want to find the probability that a customer waits a total of less than 30 minutes. So let's look at the theory of double integral in probability. The joint density function of S and Y is function f of two variables such that the probability that x, y lies in a region D. If x lies between A and B and y lies between C and D, then we can sub A, B, C, D to the integration. And note that probability must not be negative and are measured on a scale from 0 to 1. And solution is we let x to the waiting time to buy a ticket at average 10 minutes and y to the waiting time to buy popcorn average 5 minutes. And since the waiting time for x and y are independent and by memoryless property, so the exponential density function is more suitable model in this case. And since we want the probability that customer waits a total of less than 30 minutes, so we can compute the find probability x plus y less than 30. Then this is the region that x plus y less than 30. And after calculation, we get the answer 90.29%, and which means that there are about 90.29% customer will wait less than 30 minutes before taking their seats. Thank you.
Okay, very clear presentation. So 30 minutes, I think movie start already.
Yes.
Okay. So any question from the audience? Yeah. Yeah. Why the region is the real number
because in all of in R2 is actually total is 1, because if the region is at here is the 1 and another is 0. You know what I mean?
Is that asking? Why did you think why you start? Also, why you use?
Okay, for example, this chain. This chain is only one in this one. Then this is the one and another don't have this chain, so another is 0 and this is the 1.
I think Isaac asking why you use two variables.
a whole real number. So if
why you integrate over whole R2?
So if the we look at R2, this is a R2 XY band. And if the region is the whole region is here, then this is a 1 and another is 0. This is the whole probability that we can, this is the whole probability that we want.
So you mean although we integrate over whole R2, but the functions concentrate?
Yeah, this one is it's the total probability. And then this one, when we integrate, it will be 0 because it doesn't exist.
Mean in most places in R2 the function is 0.
Sorry?
In most places in R2 the function is 0, actually.
Not quite, but
我在救你，但是我就I mean, in most places, the function is equal to 0.
Yeah.
Any other question?
Okay, first, how do you convince the layman math is useful to study? I will tell them the importance of maths first, because in real life, many of things are related to maths, and if maths study well, then it can develop our words, scientific and technological level, because even though AI is also based on maths. And second, why you first choose to study maths degree? Actually, my first choice is not maths degree, since I'm a business student before, and I think I'm interested in maths, and maths. The course of maths degree can improve our logically thinking, and this logically thinking is useful for my future, whether I am a mathematician or not. Thank you.
Okay, thank you. So next we have Boon Ping. Boon Ping will first of all, let's go to astronomy.
随便啦。Hello everyone. Today I want to show Kepler first law. Okay, by the Kepler used the observation data. He find that the orbit of Mars is the ellipse. So I will prove it mathematically in this project. Okay, first this is the graph to use to prove, and this is the parameter. We will see that later. And first, by the total energy equation, this equation, and the velocity of Mars can separate to two directions. We get this equation, and plug into the energy equation, we get this equation. And then use these two formula and this substitution, we can get this equation. And then integrate it to get the integral equation. And use this one substitution, we differentiate it, and we get this equation, and sub into integral equation, we get this equation. Okay. Same substitution, we sub into the energy equation, we get this equation, and let these two constant and substitute in this equation, we get this equation, and sub into the integral equation and integrate it. This is the arc force, and rearrange it, we get the ellipse in polar coordinate equation. So we show that it is a ellipse. Okay. Okay. This proven can go into general and show that the Kepler first law, which is this. Okay. And this is what? The orbit of a planet around the sun is an ellipse, and the sun at one of the two forces. Okay. Let me go.
Then is ellipse, right?
Yes.
Why the E is constant in the energy here?
This one. Okay, because of the conservation of energy, law of conservation of energy. So the energy must be the constant. This is a physics law. Another question?
Why is it the number?
Yeah.
Question was you do a lot of substitution, right?
Yeah.
Where do you get a P equal to 1 for R?
I see from
What's P and what's
R? Okay, R is the this one, and P is the substitution. We let the equation simple. Just I think this P is can let the equation
change variable?
I think
you just change variable. It's still 1 over R.
Yeah.
But the R is changing. R is changing based on angle, isn't it?
Yes.
Yes. R is a
yes.
function in theta.
Yes, because after we rearrange it, it will be get a polar equation for the R and the theta.
I mean, R change based on theta.
Yes.
Because if you look at the picture,
yes,
the radius will change.
Yes.
Okay. Any other question? Then the orbit can be parabola or
I think this cat is ellipse because at the last we proved that it is a ellipse polar coordinate.
by chance.
Yeah, then it will be. It can be the another.
Where the E come from?
E?
Where you get the E from?
In this substitution.
In that case, you already know what is E. E is already greater than some.
No. It just it just let it is and they see that at the last it
So why is this an ellipse? This ellipse C from E or any E is ellipse? Is it true for any E?
No. It just between the 0 and 1.
Or when E is between 0 and 1, this is an ellipse.
Yeah.
So did you prove that E has to be in between 0 and 1?
No.
No? Then how you claim that this is an ellipse?
Okay, I will choose. I will find the proof. Okay. Yeah. Then that two questions. Okay, first is how to convince layman to learning math is useful. I will tell them learning math can improve our thinking skill, and this thinking skill can use in our real life. And why I first take math course, I think because I like it, and so I take it. Just that. Yeah. Thank you.
Next, we have Yi Shen. About Kepler's law also, but this is the second law. One comment on your on all of your presentation, please refrain from using these, these. Imagine you talk to a person who is blind. Can the blind person see this, that, or not? Not see, right? Okay, so make sure you describe what you want to say.
Hello. Okay. All right. My name is Xu Yushen, and I want to share with you the proof of Kepler's second law. So the Kepler's second law says that if this one is the sun and this one is the orbit of the planets, the time from here to here equal to the time from here to here, if and only if this area are equal. So it means that the area over the time is a constant. So we want to prove it. So by what we learned in AAG, we can finally obtain that the first derivative of A is equal to this equal cross product form. So this one is a constant, as I said just now. So how we prove it? We differentiate it again. Then this one must be equal to 0. And the first term is always that is equal to 0 because they are the same vector. And the second is also equal to 0. But in physics, they explain it as a centripetal acceleration. But for math, we don't believe in. So why? Okay, by just now proof, you can change the polar function to the Cartesian coordinates by a vector function, and we take the second derivative of it. And after a various calculation, finally you can get this one. And this vector and this vector are not same direction. So we claim that the first term is equal to 0. So how? By law of conservation of angular momentum, we can get is equal to 0. It's likely. So we finally can obtain the second derivative of r is the scalar multiple of the r. So it's parallel to it. So it's equal to 0. Okay, this is proven. This one is extra. I try to find out all of the dA over dt of all of the planet of solar system.
Yeah.
Yeah. You mean what is the centripetal acceleration? It means that there is an acceleration that, like, you can think like a force. It is pull it from the sun through the planet. Can understand. But this is the physics explanation. So in Chinese we call 相近加速度。它的变化里面。I don't know the physical meaning, so I try to prove it that this one. So I try to prove it. After I try to prove it, is it parallel to the? Is it this one? This one is parallel to this one. So I try to prove it up because I don't believe it. I don't believe the physics. Okay. Okay. Because the calculation is more, you can ask me later. Go back to the first statement.
So I try to prove that with equal times, both sides of the planet will swipe out equal area. Correct? No?
Yeah.
Okay. I mean, this is certainly true for a circle, right? It's true for a circle.
Yeah, also true for a circle.
It's true for circle, but in this case, it's eclipse. But for eclipse, you still swipe out equal area. So to prove this, you show that the second derivative of R
Area.
yeah, is 0.
Yeah.
So how the second derivative equals 0 prove this statement here?
And this one is the main. The first one I say is always right, and the second one is equal to 0 because this one is parallel to this one.
Yeah.
But y is equal to this. But why this one is
I mean,
parallel?
why the second derivative equals 0 implies the Kepler second?
This implies that the first derivative of a, I mean,
Is constant.
this one is a constant. Okay, this one is constant means that the Kepler first law is correct because it say that the swap area over the time is not the same. It depend on it. I mean, it's direct proportional to it.
Yeah.
Not I don't know linear because
It's constant.
yeah, it's over.
If a
It's a
function
constant.
derivative is 0, meaning the function is a constant.
Function derivative.
If f prime is 0, then f is a constant.
Yeah.
So here change of a over t is constant. This would imply that you swipe out the same area.
Same area, so the time is the same. So I mean,
Did you write this part out?
yeah, right.
So write clearly like y if dA over dt is a constant, then you have this same area on both sides.
Okay.
Okay.
Okay. For the two question, okay, how I convince the layman is I will say that it can help you to do things efficient and you can think clearly and logically. And the theory of the map will not change. It's not like the gossip will be changed or the news will be changed. Okay. And why I study in math because first of all is I like the eureka moment when solving and prove the math question, and also it's flexible to change the future area. Okay, that's all.
Okay. Does anyone know what's eureka moment? 有人知道什么叫 eureka moment？你有没有一个感觉是来，哦，我知道了，有没有这种感觉过？这个感觉就叫做 eureka moment。Okay, thank you. Yeah. So next we have Humble. Humble will tell us about ping pong. What is Humble? Did you bring ping pong here? Wow. Okay, cool.
So Humble and today my topic is about normal factor of tennis play applied in ping pong robots. And
bring your mic to your mouth.
Okay. One day in YouTube, I noticed a ping pong robot which can play ping pong very well. And if you are interested, we can watch it later. And I was shocked with this, and I started wondering how it can predict the trajectory of the ball very well and make sure the ball it hit back can land in bounds. And I found out that it's highly related with our back. Our knowledge in vector calculus. First, we can abstract the space around the table into a 3D Cartesian coordinate system, and it's like an upper level of our trajectory problem in physics in high school. And here is the definition and formulas of tangent plane for a single plane Z is defined in this way, and we can find out the normal vector and uninormal vector like this. And when a strike happens, we let the surface of the contact be the surface Z, and we can calculate out the V out with the V in we obtained by the sensors and camera, and also the pedal from the force from pedal, and then they can be used to calculate the coordinates of the ball according to time. And if we set the ZV0, we can calculate out the landing position. And they can be very helpful for the robot to adapt the pedals position and angle, and also the spring, but that's more about physics with the knowledge beyond my ability.
How about you want to stand up here and demonstrate with your bat and your big ball, like play one time for us, like demonstration.
Like
how the normal vector thing.
For each position and the angle of the racket, before hitting, the robot will know what will happen if it hits the ball back with a specific force, and the cameras and sensors will help detect the trajectory of the ball before hitting the ball, and so the robot will know if the hit will be successful or not.
Okay, so you mean that So you mean that the robot already already predict where the ball gonna fly once you place your bat, right? Even before hitting the ping pong. That's what you're trying.
When he's getting the ball, the camera and sensor will help to detect the velocity and like the position, and what he wants to know is how much what is right position to hit the ball and the angle and the force.
Yeah, so before he hit, the camera already capture the position of the bat.
Yeah.
And then maybe when he sense the movement of the bat, like the robot already calculate like what force gonna place on the ping pong.
Yeah.
And then he compute the trajectory. 明白吗？全部人知道他在讲吗？啊，就是那个机器人啊，那个球还没有打出去哦，他已经在研究这个人的动作是怎样的，他的速度，and then 他差不多击球的那个方向，他也计算了，是不是？然后再 predict 他打什么？你觉得这个是 robot 在做的啊？其实这个就是 top athlete 在做的事情。为什么他们球可以来回这么快？他就是在猜对方怎么打，对方的动作，他们已经在猜他们下一步要打什么球了。所以如果看 Olympic 看那种World Championship 他们对手打来打去很快了，因为他们已经知道他动作一出来就是要打什么球了。Robot 也是这样。Okay, yeah, thank you. So before you leave.
So for how to convince layman, first you math helps you obtain the basic computational skills and logic thinking in daily life. And also, when you learn math, when you solve hard problems, it is very you learn how to solve hard problems. You break the difficulty into some simple sections, and that's very helpful when you solve real life problems. For why I choose math, first I think I am a layman as well, so the reasons I stated now also is the reason I choose math. And also, in our math handbook, we are free to choose lessons from other departments, and we can be exposed to different things before we decide our career and future study in math.
Okay, thank you, Humble. So next, we have Xian. So Xian was specifically for GoPro acquisition. General image stabilization. So it's also capturing images that like Humble robot.
Okay, good morning, and my name is Zizang. Okay, good morning. Good morning. My name is Yang, and my topic is go for hypersmooth image stabilization, and this is the definition of stabilization. We want to remove those shake, jerk, vibration. Okay, and we carry how to say carry out with 3 steps. The first step is the global estimation. Yeah, okay, and then we given image but by the writer's consensus assumption state that okay, and then by the flow, and we can obtain the flow concern equation. And then we need to use the Lucas-Kennett method to find the general motion of UV. And then use linear algebra this square solution to find the vector U. Then the second step is motion compensation. And last we apply a average transformation and for each picture to expand my plan.
I don't say I cannot ask first, need to give you ask first. Because I take your question, I don't say. So you have to ask first. Give your question or not. Yeah, okay.
1、2、3、4、5。Yes. Yes.
Why is it inconsistent?
AU must not equal to B, because if I don't have example, I can say in general case to say the B is the那个叫什么名字？the brightness constancy, the rate of change of the brightness constancy with respect to time. A is the partial x, partial I, partial x, and the column of A should be partial I, partial x, at the x column of the what? This picture. Yeah, we skip a lot of definition, so yeah.
Okay, how you want to do it?
I think
And I think one comment is you can reduce your and reduce your D. 想好了再讲，不用急着讲，想好再讲，不用急着讲。OK，不要跟人家一问你，可能你想不出答案，跟你想想看，或者你可以想其他东西，把它来多一些。可以 let me think first，你不用来。在你想，我知道为什么你讲你这个是你在想的过程呢。对，你想的过程的时候，你可以用一些其他的那个用其他的语句把它带过，但是对，就是你可以想一想再回答人，你不用来急着回答。OK。还有一些话就是，I think 可能这边有很多 definition 吧，但是我觉得你要学一下，要想一下哪一些 definition 重要。OK， 什么叫重要呢？重要来说就是你要解释到你要做到的事情，那些能够连到你的结尾的东西，你不要解释，中间的过程可能你不用解释太。So one thing you need to learn in your presentation, why I give you 1 minute instead of 30 minutes is, I want you to learn how to pick up the main point. 你一定要 pick 最重要的东西出来吧。很多人全部都很重要 ，obviously， 因为每一步都很重要。但最重要能够解释到你的那个第二个东西，你一定要先跟人家讲，然后人家才会开始好奇说，哎，为什么这个重要呢？然后这个讲算呢？这是之后的事情哦。Okay, so before the
okay, I will ask the person if you have a language which allows us to describe, analyze, and solve our life problem, then we will learn the language. Then I will say you lie. Why don't I don't understand why don't.
I also don't understand why
yeah.
they say they don't.
So I will say just conclude that they are lying. If yes, then I will tell them, and then if yes, then go learn math. Yeah, because math, yeah, it's a universal language that enables us to describe, analyze, and solve problems logically and precisely. Yeah, and then I chose math degree because I like those. How to say? I like partial differential equation. I don't know why. Just because maybe I see those symbol feel very beautiful and hard to describe.
I love something you hard to describe, huh? Is it hard to describe? Then you got experience. Oh, your hobby. Okay, your hobby. Oh, okay, sorry. Okay, thank you, Lisa. Next, we have Gui Qi. to tell us about life belt. How do we design our life belt?
Okay. OK，等一下啊。Hello, my name is Hui Qi, and then my project is the design of life buoy. Yeah. 一样的。OK， 然后and then we will use the shape of life buoy can describe these three parametric equation. And then so we will go back to use these three parametric equation to talk about how the shape of life buoy. First of all, the cos and sin u. Sin u. Wait, 等一下。The cos and sin u can find the distribution point of on x-axis and y-axis, and then they will form many points. And then the points can connect to a line, and then they will exist many lines, and then to form a circle. Using the same concept, we find the line V, and the line V have the range between the outermost and innermost at the bigger r plus smaller r times cos V. And then we will use r sine V to represent the height. And the height also will form a circle. We know there is a circle because this equation can satisfy the equation of circle. And then we will use Jacobian to find the volume, and also Archimedes' principle to find the buoyancy. Thank you.
What's the conclusion?
Conclusion? What's conclusion?
Yeah. So after you compute everything.
Then I can find the shape of life buoy.
The shape.
And the buoyancy.
To keep you floating.
Yeah.
Any question for Wishing? Then, Helen.
Okay.
It's okay, it's okay. I have a question is it cos u will always control distribution along x-axis and sin u control? Is it possible they change?
No.
Sin u control x-axis and cos u control y-axis?
No change. Because good question. Let me think. OK。
什么？
他记得了。我讲啊。为什么这 cos u 跟 sin u？因为
So maybe I rescue a bit.
Okay.
So cos u sine. Okay, so this is because of the Newton to the parametric equation part. Actually, it's because of this part here. So you need to think about what is this u and v doing. Okay, if you think about this u and v doing, right? If you just look at plainly x and y direction there, if you square these two coordinates, what do you get? You get a circle equation. Okay, so this is a circle on the xy plane. This is what she draw on the R1, R2 there. Okay, so that u is controlling that circle. So v is should be controlling the perpendicular circle to get the inflation of this annulus, so that you get a line going. Do you get your sample here? the 气球呢？
我没有带到，因为我忘记了。
OK， 它有一个道具忘记带来。OK， 看到。OK， yeah. So actually, we spent the whole afternoon discuss about this, right? 昨天，我们昨天就是在讨论他讲的问题。Yeah. Actually, I quite surprising 啊，就是昨天其实我们讨论到4点半了，然后5点要交出来嘛，对不对？他还可以画出这样多东西，虽然我还是有一点点不满意啊，我不是不开心，我就是真的不满意，因为就是你没有解释到他刚才讲的那些东西，虽然你把东西全部打上去了，Yeah， so 能不能在 Project 2再修改一下？有对的图案了现在。但是你要想一下怎么解释 ，precisely 就是凯伦问的问题哦。为什么 U 是在讲那条线 ，B 是在讲那条？OK， 还记得吗？我们昨天讨论。
我记得。
可以吧？你在 Project 2再解释过。凯伦呢？你问题还有一个最后一个问题来。
OK。
Is inside of the right?
Yes. Yeah.
So why?
Why? Because it's 物理的东西。So the same thing, I use equation to find the answer.
You see the volume is the whole level, right?
为什么不 divide 因为还是个 question， 我等下私底下跟你讲，可以吗
？OK， 可以，私底下解决。解决好放弃 project， 解决好放弃 project 2。
OK，
thank you. Nishi, very good. Hello, very good presentation. 谁？谁？对，你还没有。
Okay. What is the use of studying maths? I will tell in story. Okay. I have a friend, Jody, and then he think mathematics is useless. One day she went shopping with her father, and then her father asked her, after the life boy discount 20%, what is the original price? And then she don't know how to answer it. She had been learned the knowledge about percentage, but she cannot quickly calculate it at the moment. After she went back home, and then she recite the concept of percentage, and she realized the math is everywhere in life. And then after that, she also realized that math can help her with many things in life, like calculating the discounts price, saving interest. So one day she tell me, mathematics can be used everywhere. And then, unlike Jody, my first choice is mathematics. because it can allow me to achieve good grade in high school. Yeah. University is different because of it's challenging. So I also will choose mathematics because the challenging let me fulfill.
You like challenging.
Maybe, yeah.
You like challenging. No, I mean like you like how to say you accept challenge, right? Because not many people like challenge, right?
Yeah.
Some people face challenge, maybe they cry.
I also will not.
You also will. Then what you do after crying?
Continue.
Oh, yes. Very good, very good. Okay. Okay. Thank you. Thank you for your very good presentation. Next we have Enzi. Enzi will talk about tornadoes.
Hello, my name is Tornado. Have this picture in your mind. This is a picture of tornado, and then we will create this parametric equation to model the motion. Okay, the path of T is the parameter in the parametric equation, and A, B, C, omega are four constants that you can determine the shape of the tornado. And then F of T and G of T are two functions that can model tornadoes' horizontal movement. And then by varying the parameters A, B, C, omega, and F of T and G of T, we can model different types of tornado in the real world. Here, I choose to vary A and B only. When A equal to B, the cross-section will be circular, which is the orange one. And when A is not equal to B, it will be an ellipse. And then I need the parametric equation and the visualization to calculate the energy of a tornado. The tornado is given by this equation. And then where rho is the air density, depend on the temperature, pressure, and also the humidity level, and v is the speed or at time t is a function of t, but we will take the modulo of it. And then in spherical coordinate, we can change the integral domain into this. We can have four non limits, and we only need to determine the other two unknown using the using this graph we have drawn, and then that's all.
Thank you. So, Ryan, can you go back to this one? Okay. So, yeah, right. So this is if A is not equals to B, the cross sectional ellipse. So actually, for the Kepler law just now, for Isaac and Pumping, right? So what you consider is just 2D, right? Actually, in reality, in this solar system, actually they move like this. Actually, this is the actual trajectory that it takes. So if you like, you can try and think about what happened. Yeah, any question for tornadoes? Like why you want to choose tornadoes?
Because first when you teach cosine, when you teach these three parameter parametric equation, I find that the picture you show is like the tornado, and then I was like, oh, nobody choose tornado, and then I choose it.
So you grew up from a country that has tornado?
No.
Okay, so before you
Okay, and then I'm going to let you guys see the tornado simulation to convince the layman about why maths is useful. First, we will modify the volume. We modify the rotating speed of the tornado, and then I let it go, and then you will see the damage of a tornado, and then you will like, oh, math is really useful because we can estimate the damage, and then we can minimize the potential damage of a tornado, of any disaster, natural disaster. I choose to okay. And then why I choose to study maths? First of all, I don't like to write essay because my English is not that good, and then I like symbols, so I just choose mathematics. But at the first time I didn't choose maths. Oh,
good.
Ding, ding, ding. Thank you. Thank you.
Xiao Yang.
Xiao Yang. Okay, we have Xiao Yang about distribution of a space vehicle. What do you mean by space vehicle? Rocket?
Aircraft. Spaceship.
Okay. Aeroplane.
Yeah.
Okay.
Hello everyone, I'm Xiao Yang, and my topic is the surface temperature distribution of a space vehicle. When a spaceship return to the ground, its high speed may causes a temperature as high as 10,000 degrees. In order to prevent the damage of the spaceship, we need to know the temperature distribution on the surface of the spacecraft. To solve this question, we can simplify the spaceship aircraft is an ellipsoid, and a coordinate system is represented with the center of the ellipsoid as the region, and according to the test data, and we can know the temperature function of the aircraft can be said as. Let's solve the actual problem. Is this, and to solve this question, we need to use a Lagrange multiply method. We construct the Lagrange function and find each partial derivative and make it equals to and solve the finish.
Okay. Also, so actually it's similar to what what's your did, right? Use the Lagrange multiplier.
Yes, similar.
Yeah, any question? Any question? Maybe not Xiao Yang, Xiao Peng. Xiao Peng, right? Using the method. Like you want to ask him. It's hard. Because they有点差别。有没有问？我知道，我问你，你有没有问题要问？没有问题，只要他讲得很清楚。Okay, so before you finish, can you answer 2 questions?
I think math is a very fundamental and universal program. It is a basic of a mostly program, and it can cultivate our logic and construct ability. And you want to discover the essence of the nature. The mathematics is the most important tools. And this program is challenge for us. That's all. Okay.
Okay, thank you. Oh, please, okay. Thank you. So next we have Chuan Yu for pipe for 发现啊，小杨啊，是一个人不讲话，但是讲起话来很长气的一个人。
喂，
以后可以说。
喂，哎，Hello，怎么翻译来着？I will show how calculus be used to get the velocity distribution and volume flow rate in cylindrical pipe. So it's a laminar flow of incompressible fluid in horizontal cylindrical pipe, and we define these parameters. And we analyze the two forces acting on a thin cylindrical fluid element, and we have the pressure force, the pressure gradient generates the pressure force driving the fluid motions, and the viscosity opposes motions, creating a viscous shear force along the lateral area of the cylinder. And at equilibrium, the add of the two forces equals 0, and we substitute and simplify to get these equations. And we generate both sides. This gives us an expression with a constant c. Then we apply the boundary conditions V equals 0, which means no slipping conditions along the pipe wall. And we can solve the results. Shows that the velocity distribution in the pipe is parabolic. And the total volume flow rate, we can integrate the velocities over all cross sections, and we put in the polar coordinates. We can get the final expressions for the volume flow rate.
Oh, okay. So what are you calculating? So you have a fluid flowing inside a pipe, right? And then you want to compute the volume flow rate. So
the velocity distribution.
How fast it flow or?
And the velocity distribution and the volume flow rate.
Okay. So it depends on two forces.
Yeah. Two forces, the pressure force and the viscous shear force.
Pressure force coming from because of the cylinder dragging.
Because the fluid has viscosity. Viscosity. 这个他们粘住了，然后不让它动。
We stick with the pipe.
With different layers of the fluid.
Different layer of fluid.
Yeah.
Okay. Any other questions? Yeah.
So why emphasize the flow characters? And because it limits the conditions and to simplify the physical analysis and the mathematics model. And with those limitations, and we can assume that the motion of the fluid only in the actual direction. And we only need to analyze the two forces in the direction is the pressure force and the viscous shear force. If we don't have the limitations, the flow may be very complex. Maybe it becomes turbulent.
so we cannot analyze it with a simple mathematics model. Maybe use other ways like Navier-Stokes equation. Okay.
You can answer the last two questions.
Why math is useful. I think math is a language to describe the world. Like we use words to tell a story, we can use mathematics to express complex ideas and give all complex things a clear logic. And we organize the complex things with formulas and logic and translate them into a simple form that we can understand, we can analyze, and we can predict them. And why I choose to study mathematics. Because I want to develop some basic skills like logical thinking and improvement my learning ability.
Okay, thank you. We have two more. Xiao Ying, about cooling project.
Okay, hello everyone, I'm showing distribution during cooling of hot coffee. And imagine you have a cup of hot coffee. Have you wondered how does the heat get lost in different regions of the coffee? We assume the coffee container is a standard cylinder, and we combine the of cooling. Can use triple integrals to calculate the heat distribution in the coffee. We divide the region into center and edge. Integral step by step, we can get the final result in central region, edge region, and adding the two region, we can get the total heat. And for 350 ml of coffee, we plug in the known values. Then by using MATLAB, I draw the graph. This is the edge distribution and center distribution. And this is total heat distribution. Thank you.
What's the conclusion?
Conclusion here is we can calculate the region heat distribution in the three-dimensional. So I get the edge heat distribution is cools faster than the center region.
Okay, any question? Yeah, for the Formula 1.
This is from the Newton's law of cooling. Newton 薛定律. This is the law of cooling is simplified from the heat transfer equations.
Is your cup model using? There's a vacuum inside you. There's a vacuum in between your center and action. So can you go back to the cup picture? Yeah, this picture here. So what's in between center and the action? This is the vacuum part.
中文是什么？
中文，中文，中空，真空。 是真空嘛？就是 center 跟 H 之间，它是什么？它是真空还是
Just divide into two regions, not 不是真空。
不是真空？
对。
哦，就是纯粹就是一个杯吧。
对。
啊，OK。
然后它是
我以为是像那种保温壶的概念。
没有，它是盛满了咖啡来算的，把它分成两个部分。
Okay. Yeah.
And it's useful because it helps us solve real world problems. For example, in my project, I modeled how coffee cools using integrals, but this same math is used in everyday applications, like designing better thermal bottles or optimizing energy used in buildings. When I chose mathematics, I started in software engineering, but switched to math to understand the principles behind the tools I loved using, like programming. Math provides powerful ways to solve problems and explore the world.
Okay.
Thank you.
Okay, thank you. We have the last one, the last but not least, we have Ziying. Tell us about time rolling.
都可以，只是我
哪一个？这个。
这个。没有，因为我没有想到是用麦的，我还以为就是要用嘴巴讲。有麦的话就。Hello.
Hello. Okay. Good morning, everyone. My topic today is space-time volume. We know that space-time is curved by mass. And from Einstein field equation, we know that metric tensor can describe the curvature. And our approach is to start from a flat coordinate surface, which is a Minkowski space, and then generalize it to a curved surface. Look at this picture. For the curved surface, when enough, the space at that local small region can actually be expressed as a flat surface. Once it is a flat surface, we can use this Jacobian and multiple integrals to first form the formula. And then we are trying to connect the Jacobian to the metric tensor. After some proof, we are able to show that determinant J is equals to square root negative G. And substitute this into our formula, we get our volume formula. And this graph shows when the object is farther away from the black hole, its volume increase. On the other hand, when it is closer to the black hole, its volume decrease.
Any question before I ask? Question?
Oh, five. Locally. Because we need to define locally first, because if we define locally, then that space is flat. Then we can calculate using Jacobian first, and then we use after proving, we relate it to the metric tensor. Metric tensor is actually can describe the whole curved surface.
Manifold. Manifold. What's the connection to manifold?
I think because it is
There's more particulars for the manifold.
Because this Minkowski space it is a one-to-one transformation, so it preserves the structure of the whole surface. Are you asking this?
局部定义体现出这个能力。
What helps to understand this metaphor by defining this Minkowski space locally?
Yeah. 他问那个 manifold 的 properties。
就是你 start with 一个 metaphor 嘛
OK。
Then 他说为什么要 define 这个 Minkowski space locally 在这个 manifold 上面
Because you want to define locally to first form a volume equation about just for transformation between coordinates first, and then we generalize it to a curved surface.
Why can you do that? Why it makes sense to do that?
Oh, because the metric tensor is this is due to the property of metric tensor, because the metric tensor is fine for the curvature one.
Okay, I have a question on metric tensor. So why is that the metric tensor? The metric tensor should be the one-to-one transformation we learned in class, right?
Yes.
So how do you see it as a one-to-one transformation? So like, for example, I want to ask you that this matrix, what are the entries of this matrix represent?
Oh, this matrix actually represents. This matrix actually is.
Can you write down the transformation here? Yeah, so what's the one-to-one transformation here? So this transformation is going from R4 to R4, right?
Yes.
So then what's that?
Viewing from the transform one point to another point in a one-to-one way.
Okay, so my question was like, for example, T, X, Y, Z, W.
Okay.
Where you send T, X, Y, Z, W.
Oh, they just send it to another coordinate, also in the flat surface.
Can you write down the one-to-one transformation? Can you write down the one-to-one transformation? Yeah. For example, in our class, we do the spherical transformation, right? Spherical coordinate. Transform from Cartesian to spherical. Or changing from spherical to Cartesian.
From spherical, and it actually, because the coordinate is.
So I mean, in class we did like sending these rho, theta, and let's say rho, cos, phi, cos theta, phi, sine, sine, phi, right? So this is going from spherical. Wait, let me think. Okay, and yeah. We have 4 variables, right? So let's say x, y, z. It's the transformation here.
Oh.
From this tensor. So after you do that, then the space becomes flat.
Then I use the Jacobian transformation to transform to another coordinate.
Oh, wait, let me think. So why not you just compute on x, y, z, w then instead of compute on minus?
Because we got many space-time maps.
What do you mean?
We got
This is one of the map.
yes, this is the
So you mean I can change?
change whatever coordinate you want. But for the space-time map,
You know,
for example, the square shell coordinate, t theta phi and t theta phi and r, these four coordinates.
you know when to use which answer?
If you want to describe a big masses object, for example, the example I give just now, the black hole is a big mass. And then we use the t r theta phi to represent, we set the big mass as our origin. And then the r is the distance between the origin, and theta and phi is the corresponding, similar to our spherical coordinates. Okay. And the Jacobian transformation is to transfer between the coordinates.
If not, then you can address the faster.
Is useful. First, I will tell them, actually, map is a subject that describe this universe from the things that in our nature, for example, sunflower seed, which are encoded in Jacobian sequence, until the use of math behind the cryptography, internet, all of them use math as a basic concept. And also until the spacecraft, all of them move according, the spacecraft station is actually moved according to the Pythagoras theorem. And the most important thing to study mathematics is mathematics provide a good environment for us to train our brain. Like for example, this critical thinking skills, problem solving skills, by looking how people make a difficult question into an easier, we can learn many skills, and this is very useful in our workplace and also in our life. And the reason I study mathematics degree is due to my passion and although I like calculations, but I'm inclined to the concepts, intuitions, and also the reasonings behind. I do some research about this mathematics degree and learn that it's actually deal with something like this. So I was determined to choose this course. Thank you.
Okay, thank you, Zing. Like giving a lecture here. Okay, so we have finished our seminar now. How many of you here? Okay, you want to take last picture with your friend here? Resha, you want to take picture first before you leave? You come in. You come in. Oh, you all actually. You all. Maybe you just stick like this, and then I take a picture. Then we'll conclude the day. Okay. Yeah. Maybe you can make any pose you like. Okay. One two，看不到那个Chat U 可能要坐进来了，我已经0:5了，看不到你。那个于峰也是进来一点，看一下，对，到慧琪那边全部要进来。OK， 来，you can make any pose you like 啊。1 2 3 1 2 3 Okay, so thanks for coming. I think it's quite good your presentation because you are willing to talk. Okay, brave to talk. Talk about your opinion, talk about your ideas. So hopefully in future you will learn to express your opinion or your view better. Okay, yeah. So see you in when 1 more hour. Okay, 1 o'clock. Okay, so if you want to join us for lunch, you can pay back.